Good morning. Today we are doing our last mission of this unit, mission 4, which is a little bit different than the previous ones. Today we are naming similar polygons and applying a dilation. First we're going to start with similar polygons. Remember, a polygon is just a shape that has many sides. So polygons have the same shape but are not necessarily the same size. So the ratios of the side lengths are equal. So what that means is these two triangles here, this triangle and this triangle, are proportional to each other. So when we set up a proportion, the ratio, meaning a fraction over here, this side 8 is proportional to this side 4. Oops. And then same with, for example, another side. This side 6 would be proportional to this side 3. If we were missing that 3, for example, we could use a proportion to cross multiply to solve. So the ratio of the side lengths are equal. That's what that means by just setting up a proportion. And then the last thing, this symbol right here, means that the polygons are similar. So if we were going to look at these two polygons and we were going to name them using the letters A, B, and C, not like giving them a name, like your name, this one was named A, B, C in that order. So they started from this point, went to the corner that has the right angle, that's what that line means, and then went to this point C. So they named it A, B, C, as you can see. The other triangle was named X, Y, Z because it's named in the same order, starting on the same side, going to the right angle, and then down the shortest side. They named that triangle X, Y, Z. Oftentimes, they are used different letters to name our similar polygons. Sometimes they use the same letter. If they use the same letters, they would have named it, for example, A prime. That's what this little dash means. B prime and C prime, to show that they're similar, or the figure is changed or moved. It's bigger or smaller or something like that. So we name our figures in the same order. As you can see here, I know it's a little bit tough to see, triangle LMN. So from the right angle, we have L, then to M, and then down the longest side to N. This one was named in the same way, PQR. PQR. Notice you're following the same pattern. So we're going to name these two similar polygons. I'm going to start with the one on the left, and I'm just going to go in alphabetical order because that's the order that they went in. However, on the second one, we need to make sure we follow the same pattern. Notice that these ones are not facing the same direction as well. This one over here on the right has been flipped over. So if we name this one A, B, C, D, we went in that order, this way around the circle. So polygon A, B, C, D is similar to this polygon. Now notice when we first started naming this, we started with the short side. So that's the short side, so I'm just going to highlight that so I can tell. Then we went to the longest side of the whole polygon, and this is the longest side of that whole polygon. Then continuing around, we went to the next longest side, and we have named all of the vertices. We could go back to the original, but then you'd be naming A, B, C, D, A again, when we don't want to rename the same letter. So this one would be named, if we start off in the same way on the shortest side, F first, then G, then H, and then J. So we named it in the same order as the first one. Even though they were flipped over, they were moved, or translated and reflected, we followed the same pattern. If we help looking at the side lengths, if we have right angles, that might help as well. So here we have two similar triangles in both problems, and we are missing a side length. So this is actually a review. It says find the length of the missing side length of the similar polygons. So here they named KLM, right here. They named it KLM in that order, and then NPQ. So that tells us that the LM, the last two letters in that triangle and the last two letters in that triangle, are proportional. So PQ is similar to LM. So if we set up our proportion, we know those two sides we could set up a proportion. I'm going to go from the small triangle to the big triangle. So we have a side length of 5 on the small one and a side length of 10 on the big one. We want to know the length of KL, this side right here. We know on the other triangle that length is 12. So if we follow that same pattern, going from the small triangle to the big triangle, we have a side length of 12 and a side length of X that we don't know. We do not need to use this information because we don't need the information on that side either. We only want to find the length of KL. So we can cross multiply. 5 times X is 5X. 10 times 12. 10 times 12 is 12 with another 0 on it, 120. And then the opposite of multiplying by 5 is dividing by 5. 5 divided by 5 is just 1x or x. So we have 120 divided by 12. Oops, we have 120 divided by 5, sorry. 120 divided by 5 gives me 24. So that would be answer choice C. The length of KL is 24 meters. They use the letter M for meters. Here's another question. It says Alma is 5 feet tall and casts a 7-foot shadow, shown here. At the same time, a tree casts a 14-foot shadow. The triangles formed are similar. Find the height of the tree. So I'm going to go again from the small to the large triangles, setting up my ratio. I'm going to start with the shadows. From the small triangle here, the shadow was 7. In the large triangle, the shadow was 14. And over here, the height of the small triangle is 5, and X is the height of the other triangle. So as you can see, there's kind of a relationship here. From 7 to 14, we multiplied by 2. 5 to what? Same thing, multiply by 2 if you use that strategy. Just setting up our proportion, you know 7 over 14 is a half. 5 out of 10 would be a half. 5 times 2 is 10. So using that strategy, you could see that X is 10. However, if you cross multiplied, you will get the same answer. 14 times 5 on one side and 7 times X on the other. 14 times 5 is 70. So if we divide, 70 equals 7x. If we divide by 7, x will give us 70 divided by 7, which is 10. You get the same answer no matter which strategy you use. So the height of the tree would be 10 feet. So that part there was a little bit of review. The thing I wanted you to focus on was naming the triangles and knowing which sides are similar. Alright, flip over to the back side. This is something new. If you've ever been to the eye doctor, you get your eyes dilated. That means they're changing the size of your pupil, the black part in the center of your eye. So they give you some eye drops to make your pupil bigger so that they can see in your eye a little bit better. The shape of your eye didn't change, it just got a little bit bigger. Sometimes when you go outside, your eyes dilate and get smaller. The black part in the center gets smaller because it's not letting in as much light because it's sunny outside. So a dilation is simply a transformation that shrinks or enlarges a figure. We call it a stretch or a shrink. You can stretch something and make it bigger, or you can shrink something and make it smaller. So a couple things here underneath dilation. It says scale factors that are greater than 1 stretch a figure, and scale factors that are less than 1 shrink a figure. So there are those words again. So dilation, we use the letter K to represent. So if something says K equals 1/2, that tells us that the scale factor is 1/2. So as you can see, here's our original figure, A, B, C, D, this shape here. And you can tell that this shape on the inside is the one that was changed because it has the little tick marks, A prime, B prime, C prime, D prime. And the scale factor did what to all the points? Well, it made them smaller by a half. So for example, this point right here was 4 to the right up 2, but now the point over here is only 2 up 1. So we took all of the numbers and divided them by 2, or took half of 4 is 2, half of 2 is 1. So we took this scale factor and applied it to each point and made it half as big as it was. So let's figure out the scale factor on this one. We are starting with A, B, C, D in the middle here, and you only need to look at one point. We don't need to do all of the points just to determine the scale factor. I'm going to look at this point C because it's both in the positive side. That point right there is 2 to the right and up 2. But now our new C is 1, 2, 3, 4, 5, 6 to the right and up 1, 2, 3, 4, 5, 6. So how could we get from 2 to 6? Well, 2 times 3 is 6. So each of our points was dilated by a scale factor of 3. And if you look at our points, for example, this point was at 3. 3 times 3 is 9. And that's exactly where that point ended up. So our last question here, we are given 4 points, graph triangle, or 3 points, graph triangle RST with vertices 1, 1, 3, 2, and 2, 3. Then graph its image after dilation using a scale factor of 2. So they're telling us K is 2. So let's start by plotting the points. R is 1, 1. S is 3, 2. And T is 2, 3. So kind of a really small triangle right now. We have R, S, and T. Now we need to apply the scale factor of 2. So we're multiplying them all by 2. So I'm going to start with R. 1 times 2 is 2, and 1 times 2 is 2. So we have the point 2, 2. I'm going to use red now for this one. 2, 2. That's R prime. Then point S, 3, looking at the 3 first, 3 times 2 is 6. 2 times 2 is 4, so this point 6, 4. 6 to the right, up 4. That's S prime, our new S point. And then T, we have 2 and 3, so 2 times 2 is 4. And 3 times 2 is 6. We have 4, 6. 4 up 6, that's our new T point, T prime. So there is our new triangle. It's dilated by a scale factor of 2. We multiplied all the points by 2. Your homework will have some questions similar to this. It's going to ask you to name similar polygons, so you have to write A, B, C, D, if you go in this order, is similar to, okay, this one's turned, so you're going to have to figure out how to name that shape. Then down below, you will have to plot some points and dilate by the scale factor. K is the scale factor. And 2 more on the back. If you have a scale factor that's less than 1, you're really just dividing. So multiplying by 1/3 is the same as just dividing by 3. If you have trouble with that one, we'll go over that one